All right, good morning, class. Yesterday we went over counting principle a bit more. You should have already checked your answers for worksheet 3 on the Elmo. I want to do worksheet 6 with you guys, which was also part of your homework to make sure that you know what you're doing. And then you'll have the rest of the period to work on worksheet 7 for homework. Remember that tomorrow, as in Friday, there is going to be a quiz on probability and counting principle. So, in how many ways? You bought 4 shirts, 5 pants, 3 hats. How many different outfits? Well, remember we talked about this yesterday, that you do multiply how much you have for each choice, and you will get 60 different outfits for number 1. Okay. For number 2, holding a Christmas party, we have 6 choices for trees, 6 for tree skirts, and 6 for different tree toppers. So there are 216 ways that you could make a tree. Next one. There are 8 people running in a cross-country meet. How many ways can these people finish first, second, and third in the race? Now, this is one of those more complicated ones. Okay? Dealing with people and the fact that once a person takes first place, they can't also take second place in the same event. Okay, so this is where when you fill in missing spots, you have to take away a person each time. So when we finished first, there were 8 different people that could have gotten first place. Well, once that first person is gone, we now have 7, and now we have 6. So there are 336 different ways that people can finish first, second, and third when there's 8 people running. Okay. If we take a look at the next one, it says 9 people are applying for a job at MTV Productions. The possibilities are a VJ, a host, or a camera person. Okay, there's 9, so we have 9, 8, and 7, because remember that once a position is filled, it can't be filled with the same person again. So 504 ways. All right, let's take a look at probability. It says in a jar there are 5 red Skittles, 3 purple Skittles, and 7 orange Skittles. Without looking, what is the probability that you will pick A? Okay, remember that probability is the total number of successes over the total number of outcomes. So successes over outcomes. So the very first thing you have to do in this problem, you guys, is figure out how many total outcomes you have, or in other words, how many different Skittles do you have? Well, that's going to be 15. Okay, because 5 plus 3 plus 7 is 15. So what is the likelihood of you taking a purple Skittle? Well, there's 3 purple Skittles, so this is going to be 3 out of 15, or in other words, 1/5. Okay, remember that you guys got to reduce your fractions. Okay. A red Skittle is going to be 5 out of 15, but reduce and you get 1/3. So in a bag of Skittles, when you go to pull a Skittle out, the likelihood of you pulling a red Skittle is 1 out of every 3. And then the last one, orange Skittle, is 7 over 15. 7 over 15 can't be reduced, so there's your answer. Okay, there are 12 different pieces of paper in a cup. Each paper is marked with a number 1 through 18. What is the probability you will pick? Well, remember that our outcomes are in the denominator. The total number of successes goes in the numerator. So if we are going to get a 5 or a 6, that's 2 choices. So 1/9. Okay. A 3, a 6, or 9, that's 3 choices. You got to make sure you reduce your fractions, so 1/6. Okay. And then C is very similar to A. There's 2 different times you can be successful by taking an 11 or a 15. So 2 out of 18 reduces to 1/9. All right, a number between 4 and 13. Notice it says between, okay? It doesn't say that it equals 4 or 13. So those numbers would be 5, 6, 7, all the way up to 12. Because it wants numbers between 4 and 13. So 1, 2, 3, 4, 5, 6, 7, 8. 8 times we could be successful So 8 over 18, reduce your fractions, it's going to be 4/9. Okay. A number more than 12, so that's going to be 13, 14, all the way up to 18. Okay. Once again, it says more than, so you do not include the number 12. That gives me 6 over 18, which is also the same thing as 1/3. Take a moment, about 30 seconds or so, look over these, ask your DFF any questions that you have, and then we will continue. All right, let's take a look at the next examples. It says a bag contains blue marbles and green marbles. The probability of picking a green marble is 1/4. What is the probability of picking a blue marble? Okay, remember we talked about 2 days ago that you're always adding up to 1 when working with probability, or 100%, whichever way you want to look at it. Okay, so right now we have 1/4. So that means that the picking a blue marble would be 3/4. Because 1/4 plus 3/4 is 1, so we get a whole bag. Okay. So same thing here, we want to add up to 100%. So 28 plus 26 plus 27, that gives you 81. So 100 minus 81 gives you 19. So 19% of the students at Fremd High School are juniors. All right, let's fill in the Venn diagram. It says 43 students play volleyball, 32 play lacrosse, and 12 students play both. Okay, remember that this region where the Venn diagram crosses each other is where it's considered both. So volleyball, we have 43 students. Lacrosse, we have 32 students, and we have 12 students that play both. Okay, in the next Venn diagram, we're going to take it a little bit further. So once again, remember that the middle section represents both. So from survey results, 25 people prefer Pepsi, 35 prefer Coca-Cola, and 10 drink both. So how many people drink Pepsi all together? Okay, that's the key word there, all together. It doesn't say exclusively. If it said they just drink Pepsi exclusively, you would tell me that there's 25 people. If we said how many people drink Coke just exclusively, you would tell me 35 people. But they want to know how many people drink Pepsi all together. Okay. Well, 25 drink exclusively, 10 drink both, so we have a total of 35 people drink Pepsi. Okay. All right, let's do the same thing for Coke, even though it's not on here. Okay, 35 people drink Coke exclusively, but there's 10 more that also drink Coke, so 45 people drink Coke all together. Okay. All right, that concludes today's video. You are to now work on worksheet 7 for the rest of the period. Please use this time productively, as you do have a quiz once again tomorrow. Okay, I hope that I hear a good report from you guys, and hopefully I'll see you guys tomorrow. If you have any questions, just make sure you ask each other or the substitute, student intern, or the TA. Okay? Have a good day, you guys. Hopefully I'll see you tomorrow.